Welcome to part 2 of my shell scripting tutorial. In this episode I will be talking about variables. Now the topic might not seem like it's a big enough topic to warrant its own video, but there's actually quite a few ways for accessing variables in the POSIX specification, so that's why it's a complete video. First I will be going over assignments, how to assign basic values to variables, but also more complex usage such as running a command and storing the result of that command in a variable. Then I will be showing how to do some basic calculations in the shell. I will discuss the various ways in which you can access variables in the POSIX specification. And lastly, I will show what we've learned in some simple example scripts. In its simplest form, we assign a variable by entering the name of a variable, an equal sign, and the value we want to assign. We refer to the variable in the same way as we refer to parameters, with a $sign and then the name of the variable. So you could say that parameters are variables named with numbers. Now a couple of words about white spaces. You cannot put a white space here because this is a completely different meaning for the shell. Now we're executing the command A and we're passing it a parameter with the value equals 1. If you want to use spaces in a parameter value, we need to use string escaping as we did in the previous video. You can use any of the string escaping mechanisms we discussed. It's also possible to refer to variables in the value of your variable. So here I'm creating a fully qualified path for the script. But what if we want to store the result of a command, say the ls command, into a variable? This isn't going to work because this just literally stores ls. In order to do this, we need to use a subshell. So a subshell, we create them with the $sign and then the command we want in parentheses. The subshell is basically a separate invocation of the shell which executes the command and then returns the result. And here you can see that the result's been stored into the variable. Now please note that this command, which does print ls, is not the same as this command. As you can see here, wait, let me do this differently. What you can see here is that the echo ls command is being executed, which results in ls, which is being executed, which gives me this output. And in this case, only the first one is being executed. Now originally the Bourne shell didn't have a way to do math. So you would call an external command called expr, which would do the math for you. Now in more recent versions of the POSIX specification, there's actually a mechanism in the shell to do this, which you can actually do in the terminal. So this is a built-in mechanism to do mathematical expressions. You can use variables in these expressions. The The syntax that's being used for the subshell with the single parenthesis and the calculation syntax with the double parenthesis, I personally am not very happy with that. I think it's confusing for beginning learners of the shell scripting. In the Born Again shell, it's even worse because you have two syntaxes for tests, one with single square brackets, one with double square brackets, and those two tests might give the same result, they might not, depending on the test that's being performed. This is another one of these things where I think that if we were to design shell scripting from scratch, we would make better choices there. So let's look at the various ways in which we can access variables. Now you've already seen the most basic form, just give me the value of the variable. And in this section we will be talking about the curly brace syntax. And if you put a variable within curly braces, then there's a couple of ways in which you can change the way the value is accessed. So if we add a hash before the name of the variable, it shows us the amount of data that's in the variable. Now we've seen the unused variable flag in action, which complains if a variable has not been set. I'm going to turn off error handling for now, because I want to show you some of the ways in which you can handle variables which haven't been defined. So here you can see that the variable hasn't been defined, and if I add a question mark after the name, we will get an error for this variable. Basically, this is the unused flag, but only for a single variable. You can even set a custom message. And you can use variables here too. Now the next character we can use to change the behavior of accessing a non-existing variable is we can use the dash. If we use a dash, we can set a fallback value to use for this variable. And if the variable hasn't been set, we get the fallback value instead. Now as you can see, the variable hasn't been defined before, and it also hasn't been defined after usage of the variable. But if we use the equal sign, then not only do we use the fallback, but we actually set the variable to the fallback here. Now there's a last one, which is a little bit odd, which replaces the value only if it is set. That can be useful for debugging, but I'm not going to pay a lot of attention to that because you won't find a lot of use for it normally. Now, we only get the replacement value if the value hasn't been set. And in this case, I've defined a variable spoon, but I've given it an empty value. Now all of the 4 checks which I just mentioned, you can add a colon before it, and then it also triggers on empty strings, but not if the value has been set. So there is one more way with 4 variants for accessing variables that I want to discuss. Let's return to the path variable which I discussed earlier. And here you can see that we've created a path to the current directory, and let's run it like this, and the current file appended to it. Now if we follow the variable name with the percentile character, then we can enter a wildcard expression that will be removed from the variable. Here you can see that something matching a slash in any kind of character, any number of characters, has been removed from the path. Now, if we don't want to remove the smallest possible part, but the largest possible part, then we use 2 percentile characters, which in this case has an empty result because the entire variable starts with a slash. Do we have a better example? Yeah, so to remove a smaller part, I'm going to add a D to the pattern because the D is here and it's here, but it's not here. So if I run it now, then it only leaves the first part. Now if we want to remove something not from the end of the variable value, but from the beginning, then we use hashes instead. So let me add an extra slash to the pattern to make it a little bit clearer. So if we take the variable and we have the pattern slash any character, any amount slash, then this is the maximum matching part and this is the minimum matching part. So in the first example with the minimum matching part, we keep this part is being remained, this part remains. And in the second example, this whole string matches and only demo remains. So as the first example, I am going to create a script which allows me to run an arbitrary command and measure how long it takes for that task to complete. So if we want to get a timestamp under the Linux shell, then we can use the date command with a little bit of a funky syntax. And this gives us a timestamp in nanoseconds. So let's create a script which measures the time before we invoke the command and the time after we invoke the command, subtracts the 2 numbers, and prints it. So these are actually nanoseconds, not milliseconds, which is a little bit too much accuracy. So we divide it by 1,000,000 and we get it in milliseconds. So apparently it took 2 milliseconds just to run the date command once. So now between the timing of the start and the stop time, we could run a command, such as, for example, the sleep command. And you see that it takes about a second to complete. But we want to run an arbitrary command. So we can give arguments to the script, and they will be placed in the all parameter script, all parameters arguments, which I've discussed earlier. As you can see, I can print it, but I don't want to print it, I want to execute it. So we'll just do it like this. And as you can see, it's now executing all of the parameters I passed as a single argument, as a single command. But if we forget to pass any parameters, then the output is a little bit weird. So I'm going to make this parameter required. As you can see, the variable is being set, however it's empty. So we want to use the second form that I discussed earlier. And you can see that we get an error message now. So now we have a little script that we can use to time any operation. And as you can see, invoking the X resolution tool Takes about 222 milliseconds, and that's probably because it actually goes to the hardware to determine the information. Now I just noticed this, but this isn't going to work. So what I'm doing here is I'm running the syntax check on the file before I set the error flag. So even if the syntax is not correct, it's still going to run the file. The syntax check needs to be done after we set the error flag. That's better. So for my second example, I want to look at positioning windows. Now, the ICE Window Manager has a couple of shortcut keys which you can use to organize the windows across your screen. But what I want to do is I want to create a script that allows me to bind shortcut keys to position a single window in a location of my choice. So as you can see from the output of the xrender command, my current resolution is 1280 by 720. But I don't want to be positioning windows behind the taskbar. So I think this window is 26 pixels high. So I don't have 26, so 26 pixels are not available in the height. So I have 694 pixels in the height and 1280 in the width. So let's start by creating a script in the bin directory. Oh. I switched users, so let's log out for a second. Like I said in my previous video, this makes it possible to run scripts from the bin dir as if they're on the path. Yeah, it's working. So let's create the script. So these two variables will contain the width and the height that I have available. And the script will take 4 parameters: an X location, a Y location, a width, and a height where to position the window. Now normally, hold on. Let's print them so we can see what's happening. Okay, so normally, with what we've just discussed, you'd think that we can just multiply this by the available width. Don't worry if it's a little unclear what I'm doing here. It'll become more obvious when I'm actually showing sample invocations of the script. Okay, so I intend to invoke the script like this, which means the left is at position pixel 0, the top is at position pixel 0, and we use the full, so one is the full width of the screen, and the second one is then the full height of the screen. So that works. However, if we use fractional numbers, and I haven't done the height yet, I'm aware of that, then you can see that there's an arithmetic problem because the arithmetic expressions in the POSIX shell expect integers and not fractional numbers. So I'm going to be using a little bit of a workaround here. I am going to be invoking an external command called BC, which is a very simple calculation language. To do the calculations. So this is better, but as you can see there's still a little bit of a problem, which is that we're getting fractional numbers in the results. So in order to solve this, I will be using the mechanism that we've seen earlier. I'm going to drop everything that follows the dot. So now we have the numbers that we want. Now we actually have to do something with these numbers. So with this command, and we're specifying the active window, we can move the window to the position of our choice. The first one's the gravity, so just ignore that one for now. The rest of the numbers are the ones we're interested in. And you can see that I just made the terminal a lot larger. But we want to position the window at the height halfway the screen, and we only want to have it take up half of the window height. So as you can see, the script is working. Now all we need to do is we need to bind it to keyboard shortcuts. So if I press the key Alt Control W, then I want you to position the window from the top left corner to the top right corner and use half of the height of the screen. And using the standard movement patterns, I will use the A for the left half of the screen, so the width is half but the height is full. I will be using S for the bottom half of the screen. So we start halfway down the screen. The height's only half. That's the width. The width is full, but the height's only half. And if I press the D key, then we're using the right half of the screen. Let's see, X halfway, Y at the top. We're using half of the width and the full height. That's about right. So now I can move the window around with shortcut keys. And to add the corners of the windows, So the Q key and the E key and the Z key and the X key will be the corner windows, corner positions. So Q is top left. All of these are just a small square that's a quarter of the entire screen. So E would be top right. No, that's the height. Z will be bottom left. That looks about right. And X will be bottom right. And there we have it. Our own window snapping mechanism with shortcut keys. I hope this was useful to you, and I hope to see you back in the next episode.